Hello, everyone. My name is Paweł Wieczorek. I work with Collabora, and I joined KernelCI development team in July 2023. Today, I would like to share with you what we've been up to, what's still in the works, and how you, kernel developers, kernel maintainers, automation or quality assurance engineers, and everyone who's involved or just interested in similar efforts could benefit from it. I will start with just a short introduction to what KernelCI actually is as a project. Next, I will describe current status of things in detail, and after that, I will talk about potential next steps that we could take. I will also show you how you could try everything out yourself. And finally, I will share with you a few closing thoughts. So let's start by explaining what the KernelCI project really is. And if we go way back to its early days in 2014, it started as an independent initiative by ARM SoC maintainers. It later became an automated system for kernel builds and boots and testing them on embedded ARM platforms through collaboration with Linaro developers. Its dashboard is something that I believe many of you might already be familiar with. Throughout the years, requirements for the system grew, and in many cases to the point which the classic or now legacy architecture could no longer support. This resulted in timed-out queries, high infrastructure costs, and also high maintenance costs. It eventually led to the idea of rethinking the design for a new KernelCI system and its instance hosted on kernelci.org, which I will later refer to as a service. Also, putting a new system in place is why the former one is now being referred to as legacy. But both system and service, however, are not the only components of the KernelCI project. Together with growing requirements, also the whole ecosystem expanded. From improving tests quality, which is an effort that only makes use of KernelCI systems, but its scope is far different from just the test execution automation, through, for example, preparing GitLab CI pipeline templates, which is for kernel development and testing, which is a project backed by KernelCI developers, but currently it's a separate effort. Also, there is another separate, completely, maybe not completely, but relatively separate effort of collecting all different testing results from various systems, not only KernelCI specifically, and delivering them to any party interested in receiving or processing them further, which is KCI DB. But back to, or maybe if one more thing, if you'd like to learn more about these efforts, go ahead and have a look at the linked materials. The one in the middle, GitLab CI pipeline definitions, is a pretty fresh one. It has been updated just last week. And now, back to the growing ecosystem. This was actually the main reason behind the new system. It had to be designed with extensibility in mind in order to easily integrate with all of those various services. But what's important to remember from this very short introduction to KernelCI project is that it has expanded and evolved into an umbrella for various efforts related to Linux kernel testing. System and service are just the components of the whole stack. and the service scaling and maintenance costs led to redesigning the whole system. Now, once we have this out of the way, let's review the current status of things and have a better perspective at various testing efforts under KernelCI project umbrella. Don't worry, we'll dissect this whole testing landscape diagram in a second. And starting from top left, we've got the inputs, so the Git trees that the KernelCI system monitors. Below that, we've got the component that is responsible for storing the test definitions, for also building all of those artifacts that will be later used, and dispatching all different tasks to other components. And about dispatching tasks, we've got the labs component, which is responsible for actual execution on physical hardware of the tests that should be executed by KernelCI. On the bottom right, we've got also other systems related to kernel testing, but not specifically part of KernelCI umbrella project, like Intel's Zero Day, Red Hat's Cookie, or Sysbot, which also feed their results to KCI-DB in the middle right, which, as I mentioned before, collects all of those testing results. And finally, we've got also a new web dashboard for presenting results to the end users. And let's start going into details from this web dashboard. It probably might be the first contact for developers who just start to interact with new KernelCI system. And it attempts at providing only relevant information instead of being a data overload for newcomers. It's available at dashboard.kernelci.org. It currently is under heavy development, so if there is something you see missing or something you see improved, you'd like to see improved, please let us know. And we'll get back to it in a moment. But where does the data for web dashboard come from? Or maybe before we go to that, let's talk about the regression tracking. Because web dashboard is important, but what we can get from it and the potential information that should be easily accessible through it would be the data on regressions found in all of those systems. There were several attempts at improving the states of things and several POCs, proof of concepts, developed recently. Currently, we're moving the most promising ones to present their data back in the web dashboard so that it's more easily accessible. And now, let's go back to where these components take their data from. And I mentioned it before, KCI-DB is a results collector from various sources, not only KernelCI systems, and it's a single point of truth for results delivery and also reporting or finding regressions. Its data can be accessed through a web dashboard I showed you in previous slides, but it also exposes its contents as a Grafana dashboard. But where do all of these test results come from? For that, we have also a component for labs for actual test execution on physical hardware, but we do not limit ourselves only to physical hardware. Virtual devices are also present in those labs. Labs also cover the compute resources for build farms. And although currently most of the hardware labs are based on LAVA, so linear automated validation architecture, the new system does not limit ourselves just to LAVA labs. It's just easiest to get started and connect more new hardware to KernelCI. But again, the new system removed this limitation, which was one of the drawbacks of the legacy one. And those labs can execute tests, but who dispatches them? Instead of the legacy, hard-to-scale monolithic application, the new system for this purpose provides just thin abstraction layers for specific tasks. And these tasks are, for example, tree monitoring to watch for changes in relevant Git trees, but also processing API events and scheduling predefined tasks stored in Maestro component, as well as reporting back the results collected from labs and submit them to, for example, KCI-DB or to the developer who created a change processed by Maestro. As you can see, there is also an email report component on the very end of the pipeline, but that's something that caused some issues in the past, mainly with not entirely reliable notifications. So that's something that's still under development, and we've got the email reports currently in the KernelCI mailing lists in order not to flood anyone with false positives. And now that we've covered the automated execution, let's go to the on-demand one. For that, we've got the new KCI dev tool, which is a standalone utility to interact with KernelCI. It supports custom submissions, even for arbitrary commits, so not only monitoring the Git kernel trees from maintainers. And knowing that not everyone might be a huge fan of web interfaces, it also allows you to retrieve the results in a machine-readable format for further processing. It will also be providing the ability to do the automated dissections from found regressions. And this feature is currently being finalized, but still under development. If you'd like to learn more about it, go to the kci.dev. The key points I'd like to highlight once again for this new system and its integrations are the extensibility that was the main idea behind the system redesign, which also resulted in a much improved scaling of the whole system. And something that I would like to stress once more, the new system is no longer bound to LAVA hardware laboratories, and that opens up the whole new way of interacting with physical devices. As for the next steps that we could take this system from, if you'd like to have a closer look at how things currently are, the easiest way to do that would be to just access the managed instances, so the either production service, or if you're more interested in the most recent changes, our staging instance of the new system. You could also try the guided way of creating your own local instance of the new KernelCI system. And there is also a semi-automatic way of deploying many, but not all of the components in this new system, stored in our KernelCI-deploy repository under local installs directory. And if you do, please let us know, I mean the KernelCI project, what you find that might still be missing from these components, but you'd like to see in the development workflow. Maybe there's something that might have been duplicated, and there is already a tested component that would suit better the testing workflow. Or maybe there's some new hardware that you'd like to see being tested by the KernelCI and connected as a hardware testing laboratory to the whole pipeline. If you have any comments on any of those topics, you can either send an email on the mailing list, or let us know on IRC channel or Matrix channel, or simply hop to our Discord server. And all of the slides have been already uploaded to the FOSDEM event page, so all the links are also available there. And now, just to summarize it all, I wanted to share with you today that the new system is steadily going through a stabilizing phase, which also comes with sunsetting the legacy one. If there is any feature that you depended on from that setup and has not been migrated yet to the new system, please do let us know. But this whole new setup was focused on delivering reliable test results and the only relevant reports. So the main idea was to prevent maintainers' burnout from increasing and hopefully helping solving it. But solving the CI needs for Linux kernel community is not really just a technical challenge. In big part, it's also a community challenge, and that is why it's crucial to continuously discuss what can be further improved, and that is why I hope I will hear from you about your experience with the new system. And with that, thanks for your attention. If there are any questions, I will be happy to answer them.
One question I have is, how do you describe the set of tests that are in the kernel? Because my understanding is that each system has its own case-of test infrastructure, EPF, and then has your own thing. How do you describe them to your system? Do you have a database of tests?
The question was about the tests database and how they can be described to be executed. So depending on your test's needs, the go-to answer would be try to write KUnit, look if there is an LTP that already supports your use case. As for the tests that are currently executed, they are like I said, KUnits, LTPs, simple boot tests, and also as most of the physical hardware labs use Lava as their underlying system, they are just Lava test job definitions. Many test job definitions are available in the Linaros test-definitions repository. I can share the link later if you'd be interested in having a closer look.
So yeah, in the past there were performance issues due to the growing ecosystem, right? There were more and more boards were added, more and more configurations. I would like to know, is there a similar trend also observed in the amount of tests getting executed? Because this could also lead to a massive blow up of databases because you have more and more results, more runs, and so on. So do you see that there's continuous grow in the execution tasks, or is it more stable in the configuration setups, or do you have any experience on this?
So the question is about scaling and how, with expanded use cases, we grow all of the components.
Yeah.
All right. Yes, the scaling, as always, is not an easy task. That's why the new system started really small with selected feature set and small number of use cases being supported. There are several ongoing efforts that aim at improving, for example, KCI DB performance, so that the queries that you'd run on this component would not simply time out, but return relevant results to you. About the growing all of the systems, yes, one have to be cautious about adding new use cases to be supported and adding more hardware, more test suites. So far, the KernelCI as a project has hit a few limits, but it's not something that the new setup does not support. It's more of the throwing more compute resources at the system problem, kind of problem.
Yeah, one last question.
How do you manage the production versus staging study? I mean by that, you have more perform that can be on staging and other on the production, or how do you share data between those two environments?
All right, so the question was about the data coming from different instances, like staging and production. Data coming from staging instance is not something that goes to KCI-DB, which is later accessed by other post-processing components. Staging data is throwaway. If we want to make sure that everything is fine, we compare it with the previous results, and if it matches, that means new release on staging is good to go, and the changes can be migrated to production. But overall, the data coming from staging is assumed that might be faulty. So before the new deployments, we compare that the key indicators are fine. We've got several specific trees monitored on the staging instance that even have branches with known issues, so that we can also test if the new deployment of the system still catches those regressions.
Thank you very much.
Thank you.